My name is Nirmal. I work for Bosch as a software architect. But I've come here for a tough topic here because I'm trying to address a problem what many of us face when we write tests, basically, right? So before I start, I want to ask you, are you all tired today? It's 5? Yeah? No? So much of energy. May I ask you to just stand up for 1 minute, or not 1 minute, 1 second. All of you, please. Yeah, all the exercises. Okay, now from this set of people, if you have broken your bones in your lifetime, yeah, just keep standing. The others may sit down. If you have not broken bones, just sit down. Oh, you have not broken, okay. Oh, okay, that's less than 50% people have broken their bones. I'm also standing because I've also broken my left hand once. Today we will not break bones, yeah, that I can assure you. So you may all sit down, and thanks for standing. One more question. Did somebody attend my previous session? I talked about Goodbye Red today afternoon. Was somebody from here in that session? Oh, good. So I could win some people. You guys are courageous to come back. Yeah. So let's get into that. Breaking dependencies. Why is this an important topic? Let's go to that. It's because when you have dependencies, you have actually so many other problems. Yeah. What do I mean by dependency is that you start developing a tool, and if you are starting well and good, everything is working fine. And after a while, you realize that there's so much of coupling involved in your code that every component needs everything else. Yeah? This is a typical situation that happens when a project is developed over a time. And then you have many problems. You change something, something else gets affected. Yeah? So these are all the typical problems what you have when you have dependencies in your code. But today, being Project Quality Day, and we also heard from the last session a lot about testing, we are going to concentrate on one aspect which the dependencies make it really tough to handle, that is writing tests, especially unit tests when you write it. Yeah? So why is it tough writing unit tests for an existing system or a legacy system when it is so much coupled? Yeah? So basically 2 problems. One is you cannot instantiate objects. This means you want to test a method in a class, and you find that the class in which this method is placed, you are not able to instantiate it, just because this method needs, or this class needs so many other things as parameters, and you're not able to just create an instance of that and say, call this method. Yeah? Or this particular class does some other object creation in its constructor, and you just are not able to instantiate this. This is one problem that you all face when you write tests, right? Agree to that? Yeah. And the second problem is that you cannot call methods from your tests. You want to test a method, and you realize that, again, this method takes so many things as parameters. Yeah? It just needs everything in your system as parameter, but you just want to test a small part of that method, but it needs everything. Yeah? Or this method calls some static methods, and it's so coupled to that class, then you cannot just override this behavior. Yeah? Static classes, these are hell, right? Agree? Yeah. So, and then what do? What's the next step you can do? You think, okay, let me refactor my code. Yeah? Everything will be better. I'm going to start it today. I'll make everything better. You start refactoring. And what happens? You are going to do it without tests. You don't have any tests in place, and you're thinking about refactoring. And you know the prerequisite of refactoring is that you should have tests in place first. Because if you refactor and you break something, you don't know, if you don't have tests, what you have broken, right? And so it's really highly risky to do some refactoring in such a situation. And you might break your bones doing that, right? All of you who didn't break, this might happen to you. So don't dare doing that. The next thing that, and then you are in this situation, catch-22 situation, because you want to write tests, and for that you want to refactor. And to refactor, you need tests. And then you just give up writing tests. It's not testable. My system is not testable. Let me do some manual testing. Let me write some UI tests. Yeah? That's what mostly happens. And then the next, somebody else comes and tell you, hey, why don't you mock all these things? Yeah? You have such nice mocking framework like Mockito or JMock or ECMock or all sorts of things. You can just mock it. I agree you can do some mocking and to write some tests. Yeah, you can get some tests in place. But the problems in your code is still there. You end up mocking because there is some dependency that you don't want, but it is there in the code. So you don't improve your code. You end up writing tests, but the problems in your code remains. Yeah? And an overuse of mocking is also bad. You might end up breaking your bones because you cannot rely your test. You don't know what you mocked, what's real, unreal, you don't know. So you might break bones again. And then we come to this, the dependency breaking techniques. What are these techniques? What is this magic with which you can do all these, that you are able to write tests, you improve your design, you don't break anything. Yeah? And that's the magic of dependency breaking techniques, because these are really low risk refactoring. And you can be sure that if you use these techniques to refactor your code, which is, I'm telling you this is again refactoring, but you will not break anything if you use these techniques. You can do it without tests in place. And then you get your tests in place after you do this. And once you have tests in place, so the dependency breaking techniques might not immediately improve your design. You're not going to get a clean code or something after that, but you will get your tests in place. And once you have your test in place, you use any of your refactoring techniques to completely refactor your design, because at any point you have your test as a protection for you. You can always see that your tests are green, I did not break anything. Yeah? So that's the two-step process that we will do, and no breaking bones with this. Right? I don't normally like showing a lot of source code during my presentations, but unfortunately, today I have to show something. Yeah? I hope it's OK for you guys that I show some source code. It's all formatted, but I show a really minimal example. It's just like a hello world example. My example is about an email client. You know what an email client could do. Yeah, you could send some mails, you could add some attachments, it might validate the address that you give in, things like that. So you don't need to understand. I'm sure the code what I'm going to show is not going to maybe also compile, but it's just as a medium for me to show you what can be the problem and how can we solve this problem. Yeah. So the first type of problem, as I already mentioned you in the beginning, is a parameter instantiation problem. Now you want to test something, and this method has a parameter which you cannot instantiate. It could be because it's a concrete implementation. It's not an interface. It's really a concrete implementation, and you are not able to create this concrete implementation from your test. Right? So to solve this, we have two techniques. One is called extract interface. I think this is a pretty famous thing, this extract interface. I'm sure you would have also done it unknowingly, maybe without even knowing this name. Yeah? Extract interface. And the second technique I'm going to talk about is adapt parameter. So the first technique, extract interface, the problem here is, as I told you, there is a method which is a parameter, and it has a concrete implementation. You are not able to create an instance of that. What do? You simply create an interface for this parameter. You create an interface out of this parameter, of this concrete implementation. So let's take this source code here. Yeah? So you have an email sender. You create an instance of email sender. And the second line, you create an instance of another class called Outlook Exchange Server, which could be really heavy. It could also have a network dependency, maybe. We don't know. And all you want to do is to send a mail, but you need to pass that as a parameter. Now imagine you want to test this send method. You would end up creating an instance of the Outlook Exchange Server from your test. And maybe you don't want that. Yeah? Could be that it needs some network access. So first thing to do is you look inside, what is send doing? As you see, the Outlook Exchange Server comes in. You just get a server name from that. All you need is a server name. And then there is some other code which sends the mail. So if you just to get the server name, now you have to create a concrete instance of this Outlook Exchange Server. So the first step, what we do here is you create a new interface. Yeah? You call it iExchange Server, and you just copy over the one single method that you need from the Outlook Exchange Server into this new interface. And take care that you don't copy everything there into this. You just do it step by step. The first thing we want is only the get server name. We just copy only that method into this interface. Yeah? And then what we do, we make our productive class implement this interface. Just implements. Nothing is broken. You have not changed anything. Nobody knows about this interface. You just implement the new interface in the Outlook Exchange Server class. And now you have to start using this interface. How do you do it? This is the old code above. And the new code looks like this. So Outlook Exchange Server has been changed to iExchange Server, right? Nothing else has changed. Nothing is broken. And now comes to testing. How do you use it from a test? We create a fake implementation. You can easily implement the iExchange server interface now, and you just override the method called getServerName and just pass some server name that you would like to have from your test. Right? That's it. And then you use the fake from your test. So instead of creating an Outlook Exchange server, you create an instance of the new fake Exchange server and just pass it to the send method. And it gets the server name automatically from your test. Right? So this is simple. You just got rid of a concrete, so you have also improved your design here. So your parameter, the method parameter does not depend on a concrete implementation. You just change it to an interface. At the same time, you manage to create a test for that. Right? The next one we're going to is the adapt parameter. So this is when you have a similar situation. You want to test a method, but this method already has an interface. It's not a concrete implementation. It's an interface. But this interface has too many methods. Yeah? And if you follow the other method, now you have to fake it. You would end up implementing all those interface methods, which maybe you decide to pass null. But this is not good. You don't know what's the consequence of passing a null to all the methods, yeah? Or empty strings if they are string return values. So what we do in this adapt parameter is that we wrap the interface in our own interface. So use basically an adapter pattern here. Another example here. There is an email sender which wants to get a domain name. You pass in a mail message. It could be a mail message, and it gets the address from the mail message, and it has some logic within which it parses and finds out the domain name of your email address, whatever is following the @ yeah? Simple. And if you see here now, if I want to write a test, I go into the mail message. I see that it has too many things, yeah? Probably more here in the end, and I don't want to create a fake implementation of that. Right? I'm interested only in one method. So I do is I adapt that. So I create a new interface again. I call it iMail message adapter. You can call it whatever you want. You don't need to necessarily call it an adapter. Yeah, you just find a name which suits your domain maybe. Or the difference is that I just have, again, the same method here, or the only method I need here. And now I implement this in an adapter class. You see that? And I take in as a parameter the original iMail message. And in the get address, I just redirect it. So it's just a wrapper for one method. I take the original class and just redirect the call to the original class. So the productive code, it looks the same. Nothing has changed for that, right? It reroutes it. But, and we use it in the production, right? This is the original method. Instead of email message, I have email message adapter. So this refactoring technique, I would categorize it as medium risk, not really low as before, because you're changing a method signature here. Yeah, you could be that there are many other methods or classes depending on this signature. So you have broken a signature, so maybe you leave the original signature as intact and create a separate method maybe for this case, yeah. So I classify it as more or less a medium risk dependency breaking technique. And you see here that iMail messages change to the message adapter. Now I create a fake implementation. Again, in the fake implementation, I can just override it and pass an email address, the to address, my own email address. And just use the fake from the test. So instead of email message, I use the fake mail message adapter, which already wraps my interface. And from the test, I just got rid of the dependency on the iMail message interface, which has too many methods. Right? So it's just an adapter pattern that you're using here. Okay, so far? Good. So then I go into the next set of problem. What you have while you write test is the class instantiation problem. This, as I said, is you want to test a method, but the class in which this method is lying, you're not able to instantiate because the constructor takes maybe too many parameters, or the constructor is doing some other object creation. It's calling a new of some class, and you're not able to satisfy all those dependencies when you want to instantiate that class. So that's a class instantiation problem. 4 methods to solve this. 4 different methods, I would say. We look into the breakout object method first. The breakout object method is used to test a method which is too long. It has too many things. It has implemented. This is typical, right? You have a God class with so many methods, and each method tests too many things. And now you find it tough to instantiate that class just to test one method. So in this case, it's easy to test that method if you move that method completely to a new class. And this class is called the breakout class. Yeah, that's why it's called the breakout object method. So you simply move the method that you want to test, the long method, into a new class of its own and test it in an isolated way. And you get rid of all the complexities in all the classes. We will see the example. Here, email sender again. There's another method called validate to address. It takes in as a string an address, an email address, and it does several steps to validate that if this address is correct. Yeah, you have used an at the rate or something like that. And then it also, you see that it also logs something. This is really bad design, that validating it is also logging something, and it's calling this private method to log. Now we want to test only this validate to address, and it's too complex now. What we do is we create a new class called email sender validator and move the only method what we need to validate to address. Yeah? One thing you have to take care is that since this validate to address needs the private method, we might have to make that private public, yeah, because we have not moved that private method there. And it's a bad design to change a private to public, right? This is not good. But we do it for now because our intention is to first get a test in place and then we improve the design. Later you might realize that it's better to move the logs and details also to the other class, then we move it. So we do one step at a time and not too many steps at a time. Right? So now we have a new class with validate to address, right? And that's also moved there. And now we make, if you still remember, here there was a parameter called string to address, and we don't have it here anymore, right? So we make that as, I'm done with the animation, right? We make that as a constructor argument here to this class, because this class needs only that. So we make it a constructor argument, this string address. And then we also have the original email sender. Since we need a private method from that, which we change to public, we might also have to pass the original email sender as a parameter here, right? In case you don't need anything else from email sender, you can just leave out this first parameter. You don't need it. You just need the string, right? But in our case, we need a private method, which we change to public, so we even pass them. And we just set them as we just set them all as instance variables so that it can be used. And then we use the breakout object. How do we use it? You simply create an instance of the new class, probably pass an instance of an email sender and an email address as a string, and then we call validate to address. Now we can test validate to address without having the complexity of all of the methods in that class. It's a really small class. You also manage to break a class into a smaller class based on the functionality. Right? Far? Good. Then we go into the next one, expose static method. This might seem a bit counterintuitive because I said static methods are bad. Now in this method, we are going to convert a non-static method to a static method. We will see why we do that. This is used when you have a method, again, in a hard to initialize class. And what we do is we change the method, what we want to test, into a static method. Example makes it more clear. You see that there is a method called compute size. It is taking an attachment as an argument, and all it does is it computes the size of that attachment. If you look at this method, you see that it does not need anything from email sender class. It's just a method which is independent. Yeah? It's somehow wrongly placed in this class. So what we do, we simply make it a static method. And once it is a static method, you can simply call it directly like this from your test. Email sender.compute size. You don't need to instantiate it. We just create a static method. And one thing I forgot to tell you here is that we add a fix me there, because you just converted a non-static method to a static method, and you write a fix me because in the long term you would find that this method doesn't need to be in email sender. We can move it out. The compute size could easily be a method on attachment. It fits there more, right? Attachment.compute size fits better. But we don't do this step immediately. We do it first as a static method, put a fix me, test is there, and then we change this, right? Okay, the next one, extract and override factory method. So we are all talking about, currently talking about methods, what's required when we have a problem that we cannot instantiate a class from a test, right? This is used when you have an object creation in the constructor. The method you want to test lies in a class and the constructor is doing some other object creations. What we do is we move out the object creation from the constructor. And how do we do it? Example, email sender wants to create a new address book, and the address book needs something called a configuration. Yeah, this is too many dependencies in the constructor, right? And what we do is we simply create a new method called create address book and move the entire implementation to a protected method called create address book. Right? So now we have a factory class, a factory method, and from the test, you just override. You create an instance of testing email sender, that's a fake class, and you just override the create address book method, and you pass your own address book, right? Because you're not interested in creating an address book. What you're basically interested is this line, add to address book. We want to test the add to address book method. That's all we want to test. We are not concerned about how the address is created, right? Clear? Yeah. Right. The next one, similar problem. Too many things done inside the constructor. Earlier we created a factory class, a factory method, overrode the factory method. What we do now, in this case, is you externalize the object creation. Your constructor is doing it, don't do it in the constructor, do it somewhere outside. This is pretty much that we always do, right? We do dependency injection. We don't want to do it in the constructor. We inject the dependencies from outside. Same example again. Address book is created in the constructor. Address book is used in a method. We want to test that method. We simply create a new constructor which gets an iAddress book as input. Then you inject it using whatever mechanism that you have, or create it on your own and pass it. One thing we have to remember is that we don't want to break interfaces, right? You had a constructor with an empty parameter, so you don't want to break that. So you still retain the old one and redirect the call to the new constructor, right? So now we have a new constructor which takes an address book as parameter. You just pass it, create in whatever way you have from outside. You create a fake address book maybe and pass it, and now you are able to test the method which uses the address book. Now we come to the last type of problems. That's the method dependency problem. This you face when you want to test a method. And again, this method might take many parameters. You don't want to pass, just like the constructor problem you had, method might take many parameters. You don't want to create all these parameters. Or this method has some part of the code which you are not interested in. You want to test something else in the method, but this part you are not interested in. Yeah? Or this method calls a static method, which you are not interested in. You can't override the static dependencies, right? And that's all the problems that you have with method dependency. And again, 4 easy ways of getting rid of this problem. First one is the most important one, and most of the dependency breaking techniques is a variant of that, subclass and override. Subclass and override, you have unwanted behavior in a method. Basically what we do is we use inheritance to nullify the unwanted behavior. Means, again example, we want to test a method called store attachment. It takes an attachment and stores it somewhere. Yeah? But there is a check called get storage limit greater than 0. It wants to make sure that you have place on the server, enough place on the server, or what's your limit. And there is some code written which reads a file stream, reads a file, a property file where a limit is set, and only after the available limit is there, you go inside the real thing that we want to test. But in a test, you don't want all these. You don't want to create a property file, place it somewhere so that it's, you want to nullify that behavior. What you do is you take this private method, what you have, and just make it a protected method. It was not meant to be private, yeah? If it was meant to be private, we would not have had to make it protected. So I think the design was bad, and whoever created it as a private method thought that nobody needs to nullify this. But since we have a requirement to nullify, it's pretty clear that it's not only for test. Somebody else might also want to nullify that. So it's better to leave it protected. And so we make it protected, get storage limit, And now in the test, we can extend it and return any value that we need. So it was checking for greater than 0, so we just pass 1 here. And now we are inside the block which we want to test, right? Too much complex? No? Simple? Yeah. Extract and override is again similar to the subclass and override. The difference, again, there is some unwanted behavior. We want to get rid of that. Extract these parts to a new method and then override. That's the only difference. You don't have a method already, so you create a new method by extracting whatever you don't want, and then you override it. Example, trash message. You want to delete somebody's message, and you see that there is a static, the session, JavaX mail session is a static class, and you're getting some session from there and creating a message and deleting it. You don't want this session while you're testing it. You just want to test this delete message logic there. So what do? We extract the method into a new method called getMessage. Oops, sorry, too fast. GetMessage, which basically has all the implementation what we had to get the message. And then we have the delete message. And in the test, we simply create a fake by overriding the getMessage and creating a mime message in our own way. Don't have any dependency to the session here, right? And then now we are able to test it further. The next one, the last two, introduce instance delegator. This is useful when you have a method, and this method that you want to test has a static reference to another class, and you have the power to change that static class. But you are not power, you are allowed to change that static class. Then you can do this. It's a very good method because if you follow this, you can get rid of your static classes also in your system in the end. You convert all your static classes to normal classes, and we don't want static classes, right? Utility classes, they're like hell in object-oriented programming. So method called static methods. What we do is, in the same static class, or in a class where there is a static method, we create a non-static method. It looks like this. There's a method called getActiveSMTP server. What it does is, it makes a static call to a class called server configuration, gets a list of SMTP servers, iterates through the SMTP servers, and finds out what is active. But there is a static reference to a class called server configuration. Yeah, it might have, again, some network dependency. We don't want that. So what we do is, and this is the static class what we have called server configuration, where there is a method, static method called getSMTP servers. What we do is, we take the server configuration class and add a non-static method called getAllSMTP servers. If you see the difference between these two methods, it's just the name that is different. This is a tough thing. You will have to find a name now. Yeah? How do you find a name? It's the same function, but you just want to create a new name. So in an example, I just call it all. Yeah? Bad design, bad interface for now. It's OK. But we just redirect the call to the service, to the server configuration getSMTP servers. Now you have in a class which had a static method, a non-static method. And once you have a non-static method, what can we do? We can override this behavior, right? And let's do that. So if you see here, this is the original method where earlier there was a call to server configuration dot get SMTP servers. Now it is not a static class. I did two steps here. I also passed the server configuration instance from outside. This is what we call as parameterized method, right? I passed it from outside, and I can use it. So there is no static reference here. And in the server configuration, the fake server configuration I pass, I can override the get all SMTP servers method with my own implementation. So I just got rid of a static dependency I had and also changed the static class to have a non-static method. So after a while, it looks like you have a static class with 8 static methods and 2 non-static methods. This is really odd. But if you write more and more tests, you will see that more of your static methods are getting converted to non-static methods, and you will have a lot of non-static methods and static methods. And in the end, you can delete all your static methods and put the implementation directly into your non-static methods. And you just got rid of your utility class. You have a class which can be instantiated, and the methods can be called. Right? The last one, very simple, parameterized method. Similar to the constructor parameterization, method creates objects internally. You pass the object from outside. dependency injection or whatever. The difference with the constructor is that it was just in the constructor, and this is a method. Just got a new name. That's it, parameterized method. Here, example, signature is being created within this method. You don't want that, so you pass it as a parameter from outside, right? And you don't want to break anything, so you retain the old method again, and then you pass it as, and you delegate the call internally. So I think that was it. I just saw the board. So perfect on time. Now I have like 5 methods, 5 minutes for questions if you have. I'm sorry that I had to show you a lot of code towards the end of the day. It's not good, but I hope you are still not tired. The slides are already uploaded. You can also refer to, and most important thing, or a lot of them is not my idea. So there is a guy who has written it called Mikhail Feathers. He has written a book called Working Effectively with Legacy Code. I would advise you, all of you, to buy that book, rent that book, and read it page to page, because it's detailed. It's not explained. Not only I've converted all of these examples to Java, but he also talks about .NET, and it's detailed. But I would still advise you to read that book in detail. Yeah, I have a question here.
Yes, in one example, you extracted the interface to get access to the
Right.
object. Another approach would be to do subclassing of this, what you want to test. What's different if you use an interface, or are there any difference?
No, if subclasses, you have to still change the signature of your method, right? You had an interface, you had a concrete implementation called Outlook Exchange Server. I think you're talking about that. Or are you talking about the adapt parameter where we wrapped something around it?
When you want to, it was one of the first slides.
Right. Right.
Use case, and yeah, it was a problem that you can't instantiate the class.
Right.
So you extract the interface, and
Yeah.
This was the use case. But you could also do a subclass
Yeah.
which you can instantiate, and override only the method you want to test.
That's a problem when you extend this class. You're talking about this Outlook Exchange Server class, for example, and it has some network dependencies. For example, when you override it, you have a lot of other methods in this class which you have not changed. These methods could have dependencies again, right? By subclassing, you don't get rid of those dependencies, what you have. And when you still create a subclass of that class, it's still, the superclass is still Outlook Exchange Server, which has all the dependencies, and you carry all the dependencies to your subclass. So you can only get rid of those dependencies, what you don't want, only if you have an interface out of it and have your own implementation for that. Else you have to override all the methods in that class, basically, every other method in that class, right? And the second method is an extension of that, which is like the adapt parameter, because we say that use inheritance less, use adapter pattern. Yeah, this is more flexible, and inheritance is really a tight coupling between classes. You can't change one with the other. So prefer adapter pattern compared to inheritance. Yeah. If it's not clear, I can come back to you again after this. Any other questions? Yeah?
So when you're saying static classes are bad, not preferable, what do we do with the util classes?
Right. Right. Good question. The question is,
Static, because they have no dependency at all.
right. The question is, why do we say that static classes are bad? So this depends on what you define as a utility class. For example, if you have a method like a getFileExtension, which takes a file name and parses it and gives a file extension, this is pretty much good as a utility, because there is no need that somebody has to override that behavior. GetFileExtension is mostly always the same, just parse it. And so this is a good fit for a utility class. But what happens in reality is that most of the utility classes that we have are not utility classes. They have behavior which somebody wants to still override it. There's an overridable behavior, but they end up in utilities because somebody found it tough to pass them as parameters from somewhere. You are deep somewhere, yeah? utility is like globally accessible from everywhere. So you just created a long method, put it inside a utility class just to be able to access them. But this is not really an example of a utility class. This should not be a utility class. A utility is only when by theory you should do it only if that method never needs to be overridable. It's always behaves the same. You have no reason to change that behavior anywhere that is used. Then it's the right example of a utility, but otherwise it's a wrong design of a code what you ended up creating as a utility. Further questions? Or you want to go for the beer? Yeah, I hear beer. Me too. So thanks a lot for coming.